Good afternoon, Miss. I am Kenverly Maantos from Section E. My report for today is all about mole method.
So, what is mole used for? Para dali ra ni siya masabtan ang mole, para asa man ni siya gamiton. Mole or mole, a standard scientific unit used for measuring large quantities of every small entities such as atoms, molecules, or particles. So, ang mole mao na siya ang masukod sa kadaghan sa molecules, atom, or particles sa usa ka matter. Like example, ang 1 dozen na ay 12 pieces, ang 1 kilometer na ay 1,000 meters, while the 1 kilograms na ay 1,000 grams. Like piyesa na sa 1 pair of socks is equal to 2. Nya ang katong 1 ream of bond paper is equal to 500 pieces. Inana ra na siyang mga kuan kanang about mole. Balik tas 1 mole. So, ang 1 mole na ni siya ay 6.02 times 10 raised to 23. Basta timan-an lang jud ni nato, basta 1 mole is equivalent to 6.02 times 10 raised to 23 jud ni siya. So, kanang kuan niha chemistry ni nga number. So, pwede sad ni nato masuwat og 600 to 6 trillion. Makita ra man ninyo sa igbaw sa, pero if gamiton ni siya medyo hassle jud. So dili pod ni dali gamiton ning number if naitay sukaton nga substance. That is why gamiton nato ang dali, which is kanang 6.02 times 10 raised to 23 atong gamiton. Next, definition of mole. A mole is defined as the amount of substance that contains the same number of atoms, molecules, ions, etc. as the number of atoms there is in a sample of pure carbon-12 weighing exactly 12 grams. Ang 1 mole kuno kay mura na siya kadaghana sa substance nga kapareho kadaghana sa atoms na carbon-12. Ang giingon ras definition, ang kadaghanon daw sa atoms, molecules, or particles in 1 mole of substance kay kapareho ra kadaghana sa atoms nga naa sa 12 grams nga carbon-12. So, since ang 1 mole kay naa may 6.02 times raised to 23 atoms, molecules, and particles. So, dapat dili dyan na nato kalimtan ang 1 mole ha. While ang 12 gram carbon-12 ay naapod 6.02 times raised to 23 atoms. So, let us have an example. So, how many molecules are there in 4.0 moles of carbon dioxide? So, first, i-identify na to ang given. Ang gihatag sa problem, which is the 4.0 moles of carbon dioxide. Next, kay i-identify nato ang being as in the problem. So, ang number of molecules of carbon dioxide. So, ayaw to ninyo ang kalimti. Ang katong 1 mole ha is equivalent to 6.02 times 10 raised to 23. So, ang para mansira ni nato nga problem, we have to convert moles to molecules. So, mag-solve na ta. So, atong given is 4.0 moles carbon dioxide multiplied by 6.02 times 10 raised to 23 molecules carbon dioxide divided by 1 mole of carbon dioxide. So we can cancel the common units. So i-cancel ni nato ang duha ang common units. Then, totalo na to ang operations needed, which is the 4.0 times 6.02 is equal to 24.08. So, nganong na 24.1 man ni siya kay gi-round off man nato sa nearest tens. So, kanang ayaw mo kalimot nga ibutang ang katong nahabilin, which is the 10 raised to 23 molecules carbon dioxide. So, gisuwat na to ang times 10 deri raised to 23 molecules carbon dioxide. Then, makasimplify dayon ta ani by moving the decimal point into left. Then, muad tas atong exponent. Depende ra na siya if kapila nato gi-move ang decimal point. So, atong case ani, move tag usa into left. Dere. So, nahimo na siyang 2.41 times 10 23 molecules carbon dioxide. So, kanang kuan, since kanang gi-move na to ang decimal point kausa, kay mahimo ang exponent kay maplasa na siya og 1. So, ang kini answer 2.41 multiplied by 10 raised to 24 molecules of carbon dioxide. So, mauna ni ang atong final answer, which is 2.41 times 10 raised to 24 molecules carbon dioxide. Mauna ni atong final answer sa first example. How much is in a mole? 1 mole of carbon weighs 12.01 gram, so 12.01 gram of carbon contains 6.02 times 10 raised to 23rd carbon atoms. So we can determine the atomic weight in any elements in looking in periodic table of elements, which is kanang 12.01 grams. 1 mole of sodium weighs 22.99 grams according to the periodic table of elements. So, 22.99 grams of sodium contains 6.02 times 10 raised to 23rd sodium atoms. Let us proceed calculating moles and number of atoms. Example: aluminum, a metal with high strength to weight ratio and a high resistance to corrosion, is often used for structures such as a high-quality bicycle frames. In a 10.0 gram of aluminum, compute the following: number of moles and number of atoms. Take note, 1 mole of aluminum weighs 26.98 grams, so 26.98 grams of aluminum contains 6.02 times 10 raised to 23rd aluminum atoms. Therefore, 1 mole aluminum is equal to 26.98 grams of aluminum. Now, let us solve the first one, which is number of moles. Atong isolve ang number of moles. So, 10.0 grams of aluminum multiplied by 1 mole of aluminum divided by 26.98 grams of aluminum. So, we can cancel the common units. And perform the operations. So 10.0 multiplied by 1 is equal to 10.0. Then don't forget to write the remaining unit, which is mole. of aluminum divided by 26.98 is equal to 0.3706 and so on. Then don't forget to the nearest thousands, it will become 0.371 mole of aluminum. Let us proceed to the second question, which is number of atoms. Then take note that 6.02 times 10 raised to 23rd of aluminum is equal to 1 mole of aluminum atoms. So, ang atong answer sa first question kay katuamang 0.371 mole. So, ato ning isuwat diri 0.371 mole of aluminum multiplied by multiplied by 6.02 times 10 23rd of aluminum atoms divided by 1 mole of aluminum. So we can conceal the common unit, which is the aluminum. Then multiplied the 0.371 multiplied by 6.02. Mao ni siya. Muna itong i-multiply. The product is 2.23, and don't forget to write the remaining unit, which is 10 raised to 23rd of aluminum atoms multiplied by 10 raised to 23rd aluminum atoms divided by 1 is still our final answer is 2.23 times 10 raised to 23rd aluminum atoms. So, mo ni ang atong final answer sa second question.